Hi everyone and welcome back. This time around we will deep dive into copper. So please meet Cunick Sense. That's our little mascot for our copper project. So during this episode, what we will do is first generate a project, a copper project. So we have a way to generate kind of like all the framework, right? Like kind of all the things you need to actually get started, as there are like a lot of like little files like you need to actually add to a copper project to be able to run it. So the first thing you'll have to do is to clone the copper projects. So today the templates, what we call the templates, are in the main copper project. Maybe at some point we will split that off, but for now it's like this. So to do this, you just get like any GitHub or Git repository, right? You get this URL, right? And you just do git clone and you put your URL there, right? And but yeah, you guess what? I probably have it somewhere, copper, right? And in copper, it's a little bit organized, and you have various kind of like big categories. One is components, basically all components that comes bundled with our monorepo. The core components are all the ones that are essential to actually run the runtime for copper. Some documentation, some examples. We have kind of tooling and so on that we put in support. Target is generated by Rust. But the one that interests us is at the end, it's templates. So when you go in templates, it's basically an extension of cargo. So cargo, we've seen during the previous video, the cargo new command, right? And what we did is we added a new command to it. But first, what you need to do is to install cargo generate. So I already have it, but if you type this command, right, that's basically the support that is able to get templates that we extended to be able to generate projects for you. So let's see how it looks like. So what you do is basically cargo cunew. But remember, you need to be in the templates directory. And there is only one parameter, is where do you want to generate your project. So I have a thing called project copper, which is like a subdirectory where I put all my copper projects. And when you do that, the first thing it will ask you is the name of your project. And that's going to be the name of the crate that will be published if you want to publish your project, or simply for you to name it. So we call that drone, right, as a project. Yeah, I need to remove it first. There we go. And there, it will ask you basically which copper do you want to use. Because depending on what you want to do, sometimes you want to debug copper itself, or you want to create like a stable project, or simply try a branch locally of your copper to test a new feature. So that's why I added this like kind of selection box, where either you take it from crates.io, which is like the stable one, the latest that has been released on crates.io. Like crates for the people who don't know in Rust are basically packages that are public packages that are published. Git is basically, it will git clone master from GitHub for those like core directories and so on we've just seen. And local means like, yeah, if you want to use your own copy of copper locally, which is useful if you want to have like a local branch and so on. So what we just want to use like the standard one, so we'll use crates.io. So that will generate like a bunch of files, and let me walk through all those files and the basic structure of a copper project. So let's go into where it generated this. And what you have, so first let's go through cargo.toml, right? That's basically where all the dependencies will be defined. That's how you define a package in Rust. So it gave like the name drone. So by default, like the default run is basically when you do like cargo run, as we have like several binaries in that crate, you need to tell cargo which one do you want. So basically this one will execute basically the main one, which is your robot executable, if you will. And that is defined in main.rs. Main.rs is your robot. But you have other like executables in usually. So the first one is a log reader. So because everything is compiled in Copper, we need to generate every time you change something in the structure of your project or your input, your outputs, and so on. We need to be able to generate a new log reader. So that's something you need to be careful about, right? Like every time you release a version on your robot, keep track of it, tag it on GitHub and so on, so you can regenerate the log reader that match your robot. We do that so we are not tied to any data format. Basically, you are tied to whatever you did with your code base at that point, which is pretty powerful because at any time you can always know that you can come back in your history and reread your logs and so on. And we will have like plenty of time on the episodes to actually go through this. And then the dependencies, like I was saying, those ones, when you just specify them with a version like this, are fetched from crates.io. And star means like, yeah, take whatever the latest one. And this one is not in the file. That's my editor telling me like, yeah, if you do that, you'll take 060, which is the latest we released like recently. And yeah, the three main dependencies. Q29 is basically like one kind of star import, if you will, where it's called a prefix, right? A prelude, sorry. And the prelude will be able to grab like all the dependencies that you need to build your application. So it's kind of a shortcut, so you don't have to fish for one dependency or the other. Helper is a little so Copper really is really flexible in the way you will integrate that in your application. And what we did with helpers is basically making something that is not really the Copper API. It's not part of the Copper API, but that's something that will initialize a lot of things like logging and parameters and so on, right? So you don't have to fight for it at the first time you use Copper. But you will see probably once your robot will evolve and so on, we might want to actually get rid of helper and go a little bit deeper and actually initialize exactly how we want Copper out of it. So that's a way to bootstrap people. But again, that's not really part of the core of Copper. And export is basically the support for the log reader. So all the things you need to be able to actually get a log from Copper and then re-export that to a known format like JSON, for example. So yeah, that's the basic things that comes with the template. When you look at the config itself. So the config will define the structure of your robot, and the structure are based. It's a directed acyclic graph, so it's a compute graph where you will have components that takes Rust structs, and chain them together and make all the things the middleware does, right? Basically taking a message, feeding it to the task, executing the tasks, taking the message out, feeding that to the next one, and so on. And there is first like a declaration and a configuration phase for the tasks, where you put the ID, you put the struct itself. So this is in our own projects, all those ones. It's just like the default I made for the templates. Basically give you like a taste of, if you were to implement those type of tasks, how does it look like in your own code base? And here we have three tasks, like with an ID, source, T0, and sync, and all their corresponding like implementation in your code. And you can have like configs after that. Like you can add things where you basically you can add parameters to. We will see that with the video, for example, right? We will be able to say, yeah, for this component, just add those parameters. And once you define all the tasks you need for your compute graph, you link them together. So this line in connection, this line basically says, you know what? Take source, this task, connect it to T0, this task, and use that message between those two tasks. Of course, you need to match the output of these tasks need to match the input of these tasks that needs to match this struct, and those like all implement like specific traits that enables Copper to actually be compiled and make those tasks compatible. All right, so we've seen that. You'll see that we generate also this build.rs. You need it, this one, because what we do is we hijack a little bit the compilation process of Rust to be able to index your logs and your log strings, and that's part of the structured logging. It's super powerful. Basically, it avoids the robot to have to basically allocate and reallocate and generate strings just to generate logs. It can just log the data without logging the strings attached to them. So that is a huge improvement compared to like standard crates we have, but it comes with that thing where you need to override a little bit the build system, and if you don't have that, you will have a message that Copper will tell you, yeah, please don't forget to have a log index there. That's going to be like where the index of those logs will be generated. All right, let's go to the code itself. So here you saw that we define tasks in our config, and they are there. So the prelude I was telling you, that imports all the traits and so on you need to define your tasks. And we will have time to actually deep dive into it, but I will skim through that so you know a little bit of the structure of that, right? And you have like, for example, for a source, we've seen the source, my source struct. You need to implement the trait cool source task, and you need to define like the input or the output. Sorry, source only has an input. You can construct there where it gives you actually the config of the tasks. You need like the freezable traits. That's going to be important because that's the way Copper will be able to take a snapshot of your tasks. Again, we will deep dive a little bit as we go, and as we develop tasks, we will go into this. And the meat of where you will actually do your implementation is in process. And process usually gets the input and output of the tasks. So for a source, it's only an output. But for like this one, that is like a standard task, a Q task, you will have an input and an output. And actually, that's a good example. And here, you basically, for example, here, I print the debug message saying, actually don't print, but record in the structured logging. I just take the value of the input and I set the output. So the output is given as like a mutable output. I basically plug the value 43 into the output. So just like dummy values, so we can just exercise the stack and see, get a feel about how it works. And the same thing, and it will just like have an input, and we'll log the output. Right, and we'll check out later the log reader. Let's look at the main just quickly. Your main application should be quick. Here we basically set up like some path for the logging. We use this basic copper setup, which is part of those like helpers I was talking about, and that's the main entry point for copper. So that's where all the magic happen. What you tell it says, you know what, generate me out of that struct. There's going to be an application. Generate me the entire copper runtime from this configuration. So the graph we define, that's where at compile time, Copper will get all those pieces and generate all the code base that is your runtime, which is interesting, right? Like that's not usually how middleware work, but that enables Copper to be very, very efficient, because suddenly you let's say you don't do something in one task, you know what? Like Copper will just kick it out, right? It will just like when instead of calling process, if you don't do anything in process, it will not call process. Or if you hard code something, yeah, it will assume, for example, if the output is always the same, guess what? It will shortcut everything and assume your output is that constant, right? So it's very powerful. Like it allows, compared to other like other middleware like ROS, where everything is very contained. The system has no knowledge about what the system is doing, basically, right? It says, oh, I need to send a message, I'll send a message, whatever happens. Copper, no, right? Like Copper, if you don't use the message, it won't send the message, it won't do anything, right? That's how, basically, the best optimization is not doing anything, right? And especially not doing anything useless. And that's what allows that. So it's a compromise, right? Like, because you first, it's going to be like harder to compile, right? It's going to be way more code to compile. It's less flexible. You can change the structure of your project while it's after it has been compiled. And but you, on the other hand, right? You'll have this trade-off where you'll get like a lot of like determinism and speed out of it. Here we define like where we want to like the base name. It's not really a path. Basically, that's the base name of the logging. So it will generate like big files. We'll see that that is the size of that actually. So now it's 100 megabytes. You choose, right, how much you want to pre-allocate. It depends on how much you will log. It depends on the size of your basically your platform, the size of what you are logging and so on. So that's why we let that as a parameter, because like sometimes you log a little small things, sometimes you log images and so on. So we'll see like when we are doing our drone project, we'll see that maybe we'll have to tune that a little bit, right? Depending on also like if we are locally there on our machine or if we are on the little embedded computer. Yeah, those kind of parameters matter. So yeah, we log some stuff at the beginning, and there we basically so this thing also created a builder for the application. So we create like a kind of a thing to help you also to build your application, and it has what we call a builder pattern, where we just make a kind of a builder first. We add parameters to this builder, like this one. We want to build this application, but take as input this context we made with the helpers, and but you can have other ones. We'll see that, for example, if we want to expose the simulation APIs, we can actually do that there. Like, oh, take this application, but please use this simulation API, so we can hook that to like the virtual world instead of using the real drivers from our real application. That's how we shape a little bit the application for depending on what you want to put, like either like a simulation, resimulation, or the real robot. We initialize our clock. That's very important, right? And we run it. After that, we initialize it. We use it, right? Like and we log it. The clock has been initialized in the context. And yeah, we'll look at the log reader later. So now you should see that it doesn't do much, right? Like if you probably read the source code, it just takes like a message generate like 42, replace that by 43, and just log that as the third step. So that's what it's going to do. We can check that by doing just cargo run. We saw that it should start our robot that doesn't do anything except like logging 42 and 43, right? So it will compile it. Yeah, the compilation time is not that bad. And you see that, yeah, it goes quickly. I don't want to fill up my, my disk of 43, 42s, right? And you see that, yeah, that's exactly what we expected it to do, right? So that exercise, the entire stack, the logging, a source, a task, a sink, everything. So it's the hello world, basically, of Copper when you execute it. Right. Now does it work on our little robot? So let's try to do what we did at the previous example and try to cross-compile. So let's see if I can find oh. Yeah, I think that's this one. No, doesn't like it. Oh yeah, I have a typo. Oh yeah, okay. Oh, it does cross-compile everything. So yeah, we don't want to cross-compile the Python part of it. So let's kick out for now the log reader for the. And we'll see. I think you can also force it to. You can actually force it to only compile one binary, but let's try again. All right, where it's coming from, this Python dependency. Let's investigate. Oh, it's coming from there. Which is export. Yeah, we forgot to remove export. That's export actually our issue. Right, now we should build. Okay, so you saw real-time debugging of that, right? Yeah, so the problem was that we were trying to also export the log exporter. That depends on the runtime. You remember that we build like a like a completely static executable, but for the export we do have a Python API, but here the cross-compiling system has no idea what's the target on the Python side. On the other side, right? On this machine, it could do it, right? But not on the target that we change, right? The target platform. So okay, now we solve that. We should have yeah, in there somewhere there release. Yeah, we have our little executable that should be able to run on our platforms, and we will do what we did just before, right? We will change that. I'll make a script because that's gonna get old at some point to to actually type this entire command, right? Let's SSH to our robot, and yeah, we have a previous one, and let's try to execute our robot. Does it run? Oh, it runs, but I put release. And release remove the textual logger we saw before. Okay, so let's go back and let's redo this because I did that. I'm not sure why. and let's push the debug version so we can see what is happening, because it was just doing it, but like with no visibility for us, right? We are in release, we do that for performance reasons, because like I was saying, we don't want to build those strings. So I completely remove a way to actually shoot yourself in the foot doing that. Right now we need to copy the, but it's not going to be release, it should be debug. Let's see if we guessed right. Yes, we did. And let's go there. It should be larger as an executable. Look at that. You see the big difference between like a debug version and a release version, right? And yes, here we go. It runs fast. Again, let's say if we can find a second, it's like, I don't know how many hertz it's going through, but it's basically probably the bottleneck is the for sure is basically the debug log. So cool. So we and look at that. Generated, like you've seen that for a few seconds, it generated 400 megabytes of those like received message and so on, right? And 400 megabytes of not like those full messages. Let's be clear, only 42 and 43s. So it was really fast. And we'll see how to disable that actually this log, because like that's going to be annoying, especially with big images when we debug it. I mean, when we want those images, we will be able to do that. But yeah. So okay, it's already 26 minutes. So we'll stop there. And so we have like one topic. So we've seen here how to generate a project, compile a project locally, execute your project locally, cross-compile your project, your Copper project, deploy your Copper project in release, in debug. We went through some debugging about like how to cross-compile when you have dependencies that are with the system. We saw that you saw me kind of debugging that live, which is interesting. And let's think about the next episode. So the next episode is going to be about like now, okay, cool. You have something that works. How do we take an existing task for Copper, add that to your project and use that, right? That's the baby steps, right? Like you could use something that is already implemented, and we will see that with the video source, because like what we are building towards, right, is basically getting a video source and basically locate those tags in the image. So yeah. See you in the next episode. And if you have comments and so on, questions about anything I'm doing, or you see a step where I'm not clear and so on, please leave a comment below, and please subscribe also if you want to follow along and hopefully go into like a flying Copper at some point. Thank you so much.